Greetings, everybody. Let's start the last topic in our discussion of trigonometric integrals. So what we'll be looking at in this section is problems that look like this, where we basically have the products of sines and cosines, but the difference being that the arguments are going to be slightly different. So in one, we've got an argument of 3x in this case. In another one, we've got an argument of 5x. And so how do we go about putting those things together to be able to do an integration? And so kind of the idea or the main thing that we'll use in these cases are really some of our trig identities that we called product. So to get our product to sum formulas, what we can do is remember our sum and difference formulas. So let's say that we remember that the cosine of alpha minus beta was going to be the cosine of alpha, cosine of beta, plus the sine of alpha, sine of beta. And likewise, if we wanted the cosine of the sum, so the cosine of alpha plus beta, that was going to be the cosine of alpha, cosine of beta, minus the sine of alpha, sine of beta. And likewise for our sine formulas, sine of alpha minus beta is going to be sine of alpha, cosine of beta, minus our sine of beta, cosine of alpha. And likewise, our sine of alpha plus beta, sine of alpha, cosine of beta, plus our sine of beta, cosine of alpha. And so the idea is basically if we wanted to figure out what a product was going to be, so let's say that we had a product that we wanted cosine and cosine. So let's say that we wanted whatever the cosine of alpha and cosine of beta was going to be. Well, the idea is that we're looking in kind of these products and we're seeing, oh, I've got a cosine of alpha, cosine of beta, cosine of alpha, cosine of beta. So these are the two trig identities that I need. And so if we kind of clean this up just a little bit. So let's say we don't need these two, don't need that identity, we don't need this identity. So we get rid of those identities, and then we do exactly what it looks like that we should do. We just basically take those two identities and we add them together. So when we add them together, what happens is that our sine of alpha, sine of beta is going to cancel with our sine of alpha, sine of beta from the first one and the second one. So those go away. On the right-hand side, now we're going to be left with cosine of alpha, cosine of beta, plus cosine of alpha, cosine of beta. So that's actually going to give us 2 cosine of alpha, cosine of beta. On the left-hand side, now we're just adding these two together. So we have cosine of alpha minus beta plus cosine of alpha plus beta. And so what do we end up with a formula? We just divide both sides by 2. And so we have a 1/2 cosine of alpha minus beta plus a 1/2 cosine of alpha plus beta. And lo and behold, we've got a formula for expressing the product of two trig functions as the sum of two trig functions, hence the idea of being the product to sum formulas. And we can kind of do this for the different combinations that we want. We can do the combination for cosine and cosine, we just did. We can do a combination for sine and cosine, and we can do a combination for sine and sine. So let's say again that we wanted to do like the problem we just saw where we had a combination of sine and cosine. So how might we get that? Okay, so if we're looking for a product of a sine and a cosine, now we look at our sine sum and difference formulas, and that's exactly what we're seeing here. We have a sine of alpha cosine of beta, sine of alpha cosine of beta, and so if we do the same trick as we did before, let's just add these two equations together. So if we add these two equations together, what happened before. Our sine of beta cosine of alpha is going to cancel with our sine of beta cosine of alpha. Those go away, so that over on the left-hand side, we're just going to be left with 2 times the sine of alpha cosine of beta. And on the left-hand side, we have these two sums, so the sine of alpha plus beta plus the sine of alpha minus beta. And so where do we get our product to sum formula? Well, we've got divide both sides by 2, so the sine of alpha times the cosine of beta is 1/2 sine of alpha plus beta plus 1/2 sine of alpha minus beta. And so there's our product to sum formula that we can use for the integral that we were given to start with. So let's see how we can apply this in that case and see how we can solve that integral. All right, so coming back to that original problem, we look at our our product to sum formulas, and remember that if we had sine of alpha cosine of beta, that was going to be 1/2 sine of alpha plus beta plus a 1/2 sine of alpha minus beta. So with this one in mind, we can just kind of plug in directly. So if we've got the sine of 3x, cosine of 5x, well, here's your alpha, here's your beta. So just plugging those in, we get a 1/2 sine of 3x plus 5x plus a 1/2 sine of 3x minus 5x. So this is going to give us a 1/2 sine of 8x plus a 1/2 sine of minus 2x. Okay, well now if we want to use our odd and even properties, we can actually take the negative from the inside of the sign to the outside. And so that's going to give us the sine of 8x. So the negative comes to the outside since sine is an odd function. So we have a minus 1/2 sine of 2x. And so this gives us an expression that we can then convert our integrand into something that becomes easy to do. So let's finish up this problem. So if we've got the integral of the sine of 3x cosine of 5x dx, then we said that one was going to be the integral of 1/2 sine of 8x minus 1/2 sine of 2x dx. And with that one, we can just integrate. So the antiderivative of sine is going to be a minus cosine. So we've got a 1/2 a minus 1/8 cosine of 8x. And then a plus, so we've got that 1/2 out in front, a plus 1/2 cosine of 2x plus our arbitrary constant. And so what happens there, kind of when we do some simplifying, 1/2 and 1/2, we get a 1/4 cosine of 2x minus a 1/16 cosine of 8x plus our arbitrary constant. And so kind of the idea that we get when we have those products of functions where the arguments are different, we're just using the product to sum formulas. So if we've got different arguments, then we go to product to sum identities. And so we know how to do that now. We can start with our identities involving the sum and difference of angles. We add those equations together, subtract those equations, get the combination that we need, and we then go from there. So hopefully this has been insightful, given you ideas for how to deal with any of these trigonometric integrals. And so I will see you guys next time.